Welcome everyone to another Stone Ridge Confab. I'm really excited today to basically connect with all of you. And hey, we've got one small win today already. The countdown didn't reset, which is fantastic. So that's a small win. We'll take it for now. So great to be here, everyone. I know we are broadcasting right now on three different sources. Basically, we're going through and broadcasting on LinkedIn, on YouTube, and on Twitch. So if you're joining, welcome. I'm really looking forward to today because we're really going to dive a little bit deeper, obviously into AI. And why is that? Well, there's just been a lot of news that's been going on about it recently, right? And I think it just makes a lot of sense to start once again demystifying it, because I guess what I'm starting to see more and more often is that people just are not fully comprehending how to use some of the tooling with it. And the reason for it is pretty simple. The reason for it is because we're all being forced on with all these technologies, right, in some ways. And I think that causes a little bit of frustration for some. And then for others, it's a brand new tool that they don't know how to use. And we've been doing this now at Stone Ridge now for quite some time. Our plan obviously converted more into, as you can imagine, the training at the very beginning here for people, but we've gone through and done a lot of updates around that. So it's just been a really, really positive thing that we have experienced as we've kind of gone through this journey. So today I want to give you that experience as much as possible so that you can be effective, obviously, with your AI-enabled initiatives in your organization. I want to talk a little bit about where the pros and cons are of this, right? Where it works and where it doesn't work, and where the market is versus the reality. And what I'm hoping is that some of you that are on here, especially on LinkedIn, if you're on there, putting comments in the chat to ask questions about it, because obviously this is important, and this is going to have a very large impact on what we do day in and day out. And if it hasn't already for you, it will, whether you want to or not. And that's something we're going to have to navigate, obviously, as a society. And we've talked about that so many times on Confab, to be honest. So I guess with that, let me just do a quick introduction myself, so you don't think I'm just some weird guy with a Dungeon Meowster shirt on. My name is Scott Frappier. My role at Stone Ridge Software is the Chief AI Architect. So what that means is I get to know all about how AI-enabled systems really interact with our business system space. I've been in the industry for about 25 years. I've had every single role that you can imagine, from an implementation specialist all the way to a developer, all the way to a project manager, to owning my own business before joining Stone Ridge Software about 12 years ago. So once again, it's going to be some really, really cool capabilities that we're going to be talking through. And there's going to be even more. And it looks like, Joe, you're already getting on it to ask some of the questions, which is fantastic. We'll definitely get to that as we go through this conversation. But really today I want to start kind of the framing around it, right, to go through that, because the Windows 11 capabilities that are being announced and added are nothing compared to what is going to be coming down the pike. And I say that kind of tongue-in-cheek because we've been talking about AI being an end user, right? We've designed systems around that where they actually act like a user, and it's so hard to differentiate between what they are and what they aren't. And so today, what I want to do, though, is really frame around the reality and the hype that's out there, and then we'll get obviously into kind of that future as well, Joe. So I do appreciate that feedback. As we go through this confab, just so you know, this is interactive. As you have questions, post them in chat like Joe had. Put it on Twitch, on LinkedIn, on any of the sources, in the comments, for example. Our stream is it looks like about a minute behind in some areas. So once I see it pop up in chat, I'll make sure to dive into that topic as well. But really what I want you to understand is that this is your time, and I'm here to educate as much as possible as we go through this. So today, really what we're looking at is we've got this concept called our AI reality check, right? Where as we posted just on LinkedIn as an example of really understanding the differences, right, when it comes to our business systems and how these systems interact basically with AI, right? And it's a term that has just been overused in our market, and I think in every market that's out there, right? And you would expect maybe some guy that's the chief AI architect to be trying to say AI is the best thing since sliced bread. Well, I think it's a fantastic thing, but I like the reality of AI, which is what are the capabilities of the solution that help businesses drive towards their goals. One of our goals, for example, is like we want to help our customers win. That's what we focus on day in and day out. So today, what I want to do is I want to talk about our real life learnings in business that we have that you should be considering as you go through this journey so that you're better equipped for the phases that are going to be coming next. And just quite candidly, if you want to see the phases that are coming next, there are a couple of industries that you can look at already to kind of know what's coming. You can look at the graphics artist industry, and you can also look at then the audiobook industry, and you can also look at, for example, the video production industry as well. That we're starting to see. I don't know if you've ever been on TikTok, Facebook, or even LinkedIn, but this generative content is getting kind of out of hand. It's kind of cool though too, but it's getting harder and harder to differentiate it. And so in the business system space, we're going to follow suit. It's going to be the same exact thing because human beings are creatures of patterns is what it boils down to, and we're going to see that as we go through this. So today what we're going to do is we're going to talk about really the AI market capabilities or the AI capabilities versus what the market claims, because I think the market is sometimes a little bit more ahead of the hype around it versus then the reality. And the reason I want to kind of start there is because the hype that was there, a year ago is kind of where we're at now, which is pretty incredible to be honest. But if you were there a year ago and you would have done a project, you might be frustrated because it didn't match exactly what you wanted during that first month of where that hype was kind of introduced. Now we're going to have another hype wave that's going to be happening obviously for 2026. And the questions that we have obviously is why inaccuracies, hallucinations as we called it back in the day, right? And how we actually use these to pattern off of it, right? So I think this is something that we're going to want to really just dig into a little bit more so that you understand really where the market is and so that you can better prepare your team for where you need to be as a part of this. So really, let's go ahead and I got a slide deck that we can talk through with this. And as you have comments, like I said, please spam the chat. Go ahead and put any questions that you have inside of there. Carly, I appreciate that as well. I'll have the chat just kind of hidden here as we go through this for now. But what we'll do is I'll pull it up then when we have some comments that come through, obviously. So I guess the first thing here is, talking through like how does AI work? Like I created this slide deck really kind of quickly to basically go through and educate people on a really high level problem that we have inside of our industry. And what is that problem? Well, it's that this term AI has been used for everything. And really, it's not everything, right? And that's a reality that I think a lot of people that are really stewards of the industry understand. I mean, when you've got Sam Altman, for example, of OpenAI stating, "Yeah, we're probably in a bubble," well, there's probably some logic behind that, right? And the reasoning for it is because there is just a lot of general excitement around it. Just examples of that, so you kind of understand where I'm coming from with it. Because once again, just taking Sam Altman or some of these leaders that are in that at their face value for a comment when it's their product that they're selling, I get it, right? Like we've got to be critical thinkers as we go through this. But when you've got students, for example, that use AI for really a lot of their interaction in colleges and high schools, and when you've got, for example, even our CEO's kids that tell Eric, they go, "I don't know how you survived college before you had AI," right? When you've got, for example, this content that is being generated, where now when you look at a video, it's really hard to tell the difference between what's real and what's not inside of those videos. When you've got the voice capabilities now that are coming out, where like even like Scarlett Johansson, right, when she went through that entire thing with OpenAI where they had a voice named Sky that was so similar to hers, that caused worry from a lawsuit and from that perspective, right, where it's really getting hard to differentiate potentially the likeness obviously of that. And the thing that's really important here to everyone that's listening to this stream is the fact that this is going to just get better and better. Like if you look at the videos that were out a year ago compared to where they are with Sora's introduction, for example, it's a substantial improvement. Less arms disappearing or 6 fingers versus 5 fingers, right? Every iteration of this is getting better from where we were at before. And so it just is going to take some time here. And we always say it's going to take some time, but the leap that we went through to GPT-4, for example, was pretty substantial. So the hype you're hearing, and let's just say it because I talk with business leaders all the time that are looking at this stuff. First off, AI can solve every issue in automation, right? Like that's what you hear. It's like we've got this awesome automation that we enabled AI and it's working fantastic. Okay? That's a good one. That's one that we hear quite often. We can throw tons of data at it. Like we can throw a large amount of data and it can tell us what to do. Like it can give us those insights that I spend hours on to tackle. Okay? We can replace our staff with AI agents. This one, right? You've heard this as well. Because it's a machine, it has the precision that we need. Because we're looking at AI being more akin to a machine than how a person thinks, even though, once again, AI-based systems, especially large language models, kind of mimic how we think, right? So it's kind of interesting that you would think that a machine, like a human being, is not very accurate when we have conversation, right? So, but that's what I hear. And then the other thing about this, I don't have to think. I can just throw my documents at it and it'll magically work. I can put it on a SharePoint site and then all of a sudden magically it'll start reading that data and interacting with it. So this is what you hear, right? You hear and you see even through some of the tooling from a developer perspective that this is what you can do. I can go into Copilot Studio, click on a knowledge source, and then upload a large PDF document. But I'm not asked if that PDF document is a narrative type of document or if it's tables that are inside of the document. Instead, what I have is a upload that I can do to add knowledge. And I have a lot of assumptions then built into that as I go through that process. And once again, this is why you need partners that understand these tools, because just because you can doesn't mean you should. And we know this as well even in our design paradigms around ERP, CRM, and business systems. Just because you can customize doesn't mean you should. Remember, you want to probably go through some testing, some scaffolding, some community support that's related to it. So this hype is true in some ways, but the problem is that people look at the end result as opposed to the effort that it takes to get to the end result. And with AI systems, you still have effort that you have to put in to get to this level as you go through that process, right? So I don't mean to be the downer in the room, right, so to speak, but this is something that as business leaders you should be absolutely contemplating, because if you're hearing something is too good to be true, what is it? It's usually too good to be true, right? So let's talk through just a little bit about this, because AI-enabled systems, they're not magic. There's a very profound science behind them, and one that most of us can actually understand on how it works. It's just that no one has really distilled it down for us to be able to really understand how these systems work. It's like an art, or it's like almost like a religion in some ways, where the priests know all the secrets around it, but then no one else does. And I think that that's kind of where we were at the very beginning. Not to interject religion, not at all, but just to give an example of it, of that knowledge of how these systems work. 2 years ago, most people didn't even understand what a large language model is, let alone what the capabilities are, let alone the advancements that have happened in the 2 to 3 years since that introduction occurred. So there's been this didn't stop when it was introduced, right? It has continued to expand upon, and the science behind it, I think, is something that you need to understand. If you're going to understand how to maintain a vehicle, you're going to have to understand the basics around it. And I think all of us are going to have different levels of this, and that's perfectly fine. But the net result is that there has to be, from a leadership level perspective, the use cases that work, right? And then as you go down a little bit further to the functional, it's going to be what are the questions that I can ask and automate? And then when you get to the technical side of it, which we're going to cover a little bit more in detail today, it's going to be, well, how does this engine or piston go up and down to create the explosion, to create the energy to do what it does? I don't need to know the exact metallurgy of it. I don't need to understand all the different weights and oil grades and how those viscosities affect, for example, the friction in it. But I do need to understand how I can build something around that engine that's going to be turning, and also understand why I get it bogged down in some situations, right? You still need to understand some of those components that you're interacting with. And technology is a tool, once again, and you should always be looking at it like that to get to your result. So the reality that leaders really face is that they go through that hype episode, and then all of a sudden they have these that come out. And I hear this all the time because they've gone with another partner that they've tried to go through and actually do this in. First off, it's inaccurate whenever I try to do something, right? So this is a really big issue where all of a sudden I ask a prompt of something and then the results of it are not very accurate. Or the system, for example, I sent a large data set to it and it doesn't seem to remember, what I said at the beginning of that data set, whether it's narrative or whether it's record-based data, for example, or the data that it gives me is inaccurate or skewed. And what I mean by that, the reason I add that versus inaccuracy is that it gives you an answer. It looks like the answer is accurate, but then when you audit the data, it's not very accurate. You give it some basic math calculations and it doesn't come out with really good results for those, right? It's inaccurate for those basic, what you would consider basic math calculations. And then the cost of it, right? Not only is it not accurate, so immediately I'm done with it because it's not helping me get my job done, but the cost of doing it was more expensive than me just doing it manually by creating a Power BI report or something else that I'm accustomed to be able to drive that. These are very common realities that everyone faces, and this is why that hype bubble versus the reality has caused a lot of friction then in terms of the market when it comes to AI. Now, there's more than that, right? Like we're talking about one small component here because there's the people factor, the political factor that's involved with this. There's also then, for example, the slop factor, right, where it does create content that's not very good, but it's being touted as very good. But at the same point, a lot of this is because of these reasons, though, in the business system space. So you probably want to know, well, Scott, it sounds like maybe you've got some ideas on how we could tackle that. And I do, because we've gone through this with our team to really tackle these for customers, and we're seeing really great results. It's not perfect results, but directionally, it's helping our customers go faster, do more, be more accurate, have more capabilities. Like it's addressing those needs while not having a substantial cost increase, but it's also an investment. And that's the other thing to note here, is that you're not going to know how to use a hammer perfectly the first time you pick up a hammer and try to use that on a nail. Over time, you're going to become better and more skilled with that. The example I love to give is the railroad spike hammer. I watched a video of a guy that just started doing that 2 months ago, and he was horrible at it. You look at 2 years later, the dude was an animal. He was able to basically go through and nail it with that railroad spike hammer, which if you've ever seen them, they're pretty thin. They're not like a sledgehammer. And it's pretty amazing what you can then do over time when you know how to learn to use that tool. So one of the things I want to talk about is really the fact that you need to know how the tool works. There has to be some demystification of how AI systems work. And if I just tell you it's AI enabled, that should be a red flag for you almost immediately as a leader. Because what does that mean? What does it really mean? Does that mean that it is something that runs a large language model? Does it run a statistical model or a machine learning model that's more specific towards a use case like time series regression? That's the first step that you should be considering with it. Because I think what's happening here is that people use this term so blanketly, but there are so many different components that are related to it that make it work. If you ask about a car, right, and I always use cars because I think they're one of the simplest analogies that people can relate to. And we can also know all the different levels of it, right? Because some people just buy a car and lease it, other people buy it to own it. Other people buy it to modify it, right? They do all these different things with that product. And when you say AI, there's going to be different people at different levels with it. But if you lease a car, for example, and you don't want to know about the technical underpinnings, and then you want to buy a different car, and somebody else tells you why it's probably not a good thing because the engine is a two-cylinder engine and has no horsepower, like a little Volkswagen, for example, and you want to go racing with it as your intent or purpose that you expressed as part of it, you're probably going to want to know a little bit more about how that vehicle works. What do cylinders mean? What does an engine mean? What's a transmission mean? Doesn't mean that you have to get to the level of detail that you're an expert, but you need to trust in people that are giving you the right guidance to help you make those decisions. And then maybe you'll get deeper into it, maybe you won't. But that's the point here, is that today we're going to get a little bit deeper inside of it so that the people that are the experts or that really want to harness this technology can educate the leaders at the right level of where those leaders are inside of your organization so that they can span that, so that you can have the leaders that don't want all the details but just want to buy the car, and then you can have the people that want to build the engine more be a part of this story, because it's going to need all those different people to really drive that forward. So the first thing that you need to really understand is the design of these systems. So just like we talked about a car, you're going to want to split your patterns into really two main buckets when you're looking at AI-enabled systems. You're going to want to basically do what I call pattern identification as one of the patterns that you're going to be looking at, and then you're going to be looking at generative content. This is a gross oversimplification because there's so many other components that you can interact with. But to start towards the middle of the line here, or we can go super deep and lose everyone on confab, or we can go super high level and lose a lot of other people. This is a really good balance then in the organization to start talking through. So examples of pattern identification. So when we think about a process inside of a business system, what we're typically doing is we're answering a pattern. We'll call that pattern a question. Hey, Cindy, can you give me the aging details for customer ABC123? Well, what is that? That is a pattern in itself. I'm asking for a customer, I'm asking for aging details, and I'm asking for a specific customer then to provide that aging details from that person. So pattern identification can be through words that we use to communicate, for example, or data that we throw at something to identify the pattern inside of that. So what do I mean by that? Well, another pattern identification would be, for example, when you have what's called time series regression. And what is that? I'll oversimplify it. That's where you send historical data to identify a trend for the future. So demand planning would be a perfect example of that, where a pattern is identified from past data that then predicts the outcome of the future, right? And what you're going to find out here, if you didn't know this already, is that both large language models and machine learning models do this in some way, shape, or form. So that's going to be important because that overgeneralization of using large language models for what machine learning models are good at, that's where we get into our problem. So pattern identification is going to be something that you're going to want to think through. The other aspect of this is going to be generative content as well. So let's talk through the pattern identification really quick. So an example of pattern identification, like I said, was going to be the statistics. Pattern identification can be tackled by large language models or LLMs, large multimodal models. So multimodal means that we can do voice, video, and text, for example. And what's interesting about these is that the accuracy with a true pattern recognition capability that deals with large data sets is typically very low for a large language model and very high for a specific use case machine learning algorithm like time series regression. So just know that to begin. Large language models, large amounts of data, bad. Machine learning models, good typically for that. And I'm generalizing, but that is a pretty well-known fact in the data science industry, basically. Generative content is going to be the output then that we use to generate basically content, right? So it kind of explains itself, right? Generative content. So when you think about that, it's not about then, for example, the question that we go back to where Cindy's going to provide an aging for a specific customer. It's going to be creating the document that then has the narrative that explains, for example, why you have your 30, 60, 90, 180-day buckets that you have, or what I should be looking at inside of those buckets, or an email that needs to be generated for the collections for the 30-day, for example. That's generating content from that pattern identification that we had inside of here. And this is candidly where large language models shine, but they only shine where the data that's being sent to them is a small amount of data, right? And we've talked about this a couple of times on Confab, and the reason I bring it up is because it's really important in your design pattern, because if you need something that's going to be with a large set of data, well, you're not going to be using a large language model. You're going to be using more than likely a machine learning model, right? And we're going to talk a little bit about why in a second here, but this is a really important concept to kind of know. Now, the difference between these, as you can see, is that, like I've talked about, is that machine learning models are really designed to tackle a task at a high degree of accuracy. One of the things that I did for our company quite some time ago, which was kind of fun, this was actually almost 3-4 years ago. We had a company quarterly meeting. We got everyone together. It was kind of funny because we had a slide deck that I prepared, and in that deck I stated that AI isn't about accuracy, it's about knowledge, right? And then machine learning is about accuracy. And people always would joke around with me on that because they're like, Scott, they kind of mean the same thing. And it's like, well, they don't actually. Machine learning models are designed to be statistically accurate for a very defined task as they go through that process. So examples of that, like time series regression, is that you're going to basically take your historical data, train the model based upon those trends to then get your output of statistical significance. And what I mean by that is that when we look at, for example, a machine learning model, we want accuracy rates of 80, 90, I'd say above 80, sorry, 90+% that we typically then drive some of those results out of. Whereas when we deal with artificial intelligence or AI, we want to be directionally accurate. And that's where I think a lot of this starts to fail for a lot of leaders because they're looking at AI as being accurate to a 90+% degree perspective, whereas what they're really asking for are machine learning models that then identify through data science those patterns with a high degree of accuracy, right? So examples basically of high degree of accuracy is taking large sets of data and identifying patterns in it, generating the statistical outcomes, so like autoregression, integrated moving average, or the profit methodology for time series based data. And what's time series based data? That could be demand planning, that could be cash flow forecasting as an example, that could be taking, for example, trends in terms of late payment predictions that uses time series regression to figure out like when does this customer typically pay, and they're very concise, and the output that they generate is not a large random capability of output. It's going to be numbers or dates that give you kind of an approximation as to when something is going to occur. And then finally, there are also machine learning models that create clusters in unstructured data. This is where the holy grail is from a leadership perspective for reporting, where I throw a bunch of data at you, and then you go through and figure out the patterns, the clusters as we call them in data science, to then identify deviations in those clusters or from a baseline that help me then explain these trends inside of my data, right? And so that's the concept of structured versus unstructured, which we're not going to cover today, but they're very common scenarios for machine learning. And the key thing here is that most of the models that are designed around this have specific outcomes of data that they provide around it. So time series regression, date, quantity needed. date, quantity needed. That is the output. Whereas a large language model can have many different outputs. Instead, inside of a statistical model like a machine learning model, it's typically then going to have obviously those specific outputs that are there. That's why they go faster. That's why they can process large amounts of data, because they don't have the same type of architecture as a large language model does. They still have neural networks and all the other stuff that we talk about, but they don't have exactly the same concept of a large language model. So basically, large data sets, if you come up to me and you say, Scott, I want to analyze data inside of my organization, I would not point you to using a large language model to do that. I would point you to using, for example, a tool like HBD scan or some time series regression capabilities in the machine learning platform to tackle those particular scenarios. Now, remember, we talked about this pattern identification. The type of pattern matters, the amount of data matters. Well, what about large language models, Scott? Like you said that they're also pattern matching machines as well as we go through this. So they are. They are absolutely pattern matching capabilities. And we're going to talk a little bit about how they work a little bit here too, because they are fantastic for smaller data sets. And what do I mean by that? Well, in your mind, let's start here because we're going to give more of this as we go through this. But for smaller data sets, large language models that are used by ChatGPT and Copilot for the prompt that you ask to then generate the content to answer a question that you may have, they're fantastic for that. Why is that? Because the smaller the data set, the better the actual results are for a particular large language model. What do I mean by that? Well, too small is a problem, whereas too much is a problem. There's usually a sweet spot inside of these large language models that allows us then to accurately take out the information that's needed in that prompt to give as directionally of accurate as a message or response as we can. So what is that number? Well, the number I typically use, team, around 64,000 characters. 64K. And I know when you hear that, you're like, what? That's all the data I can throw at a large language model? There's reasons behind it, and we'll talk about that, but this is the reality. And I'm just giving you reality because you can go test this out inside of Gemini, Anthropic's Claude, inside of any large language model, because the architectures that underpin them, the transformer architecture as it's called, work the same. There are some proprietary capabilities in the pooling phase, and we'll talk about that in a second, but the net result is this pattern is what you need to learn in order to really then be effective in terms of then working with these AI-based systems when you want to introduce a large language model in that AI-centric process. So what they're great at for a large language model is they're really good at summarizing and identifying those patterns in that small subset of data, because they can also then rapidly create content that you can use to iterate off of. Examples of that inside of, Copilot, when we interact with it, we can have a prompt and then we can ask a question of that prior prompt and it will know basically that detail from before. And so what's interesting here is that this is directionally accurate. What do I mean by that? If you give a large language model 64,000 characters, and if you, we'll use the GPT-4 or 4 Omni as an example with it, it can recall with an accuracy of around 92% what the characters were inside of that data. What do I mean by that? That means that if I have 64,000 characters inside of there, I can accurately recall the exact 60,100 characters that are in there, but other characters may be missed. And this is really important because what people are using these for is they're trying to throw a large subset of data, mind you, typically it's way more than 64,000 characters, and they're trying to make it identify patterns inside of that when it's not designed to do that. And so the type of data also matters when it comes to a large language model, because large language models are not designed to look at records. They're just not. That's not how these systems work. They're designed to look at words. They're designed to take words and turn them into tokens. They're designed to take those tokens and then look at vectors, as we'll talk about in a second here, to figure out what that word is most akin to create the output that needs to answer the context of the question that was asked. So this is a really important distinction, because if you're using a large language model to throw a massive amount of records towards it to get questions or insights into that, can it work? Yeah, it can, but the accuracy decreases substantially. We're talking hallucinations, we're talking all of a sudden you've got records that are being pulled in from another area that have nothing to do with the question that you asked, and then before you know it, your users will not touch the AI-centric systems because you've designed something that wasn't designed to do that. That's just not the way it was designed to do that. So once again, it's really important to know those distinctions. So the reality is that because we've generalized AI in terms of large language models, this has created that hype versus reality bubble that we have. This is what creates most of the frustration that I see from the customers that we interact with, because all of a sudden now they've been told all these things that they can do, but they don't understand the ingredients, so to speak, that are needed to get to the business outcome or objective. They're asking for the bread, and they're not asking for the ingredients on how to bake that bread, or how much time is needed, or what temperature is needed, so on and so forth. The exact same concepts exist with this tool. We need to know, for example, what is the prompt that needs to be answered? Where is the data that's related to it? How much data are we talking about? What is the goal of the output that we're trying to accomplish? How are the deviations of the questions going to be asked based upon the role of the end user that's interacting with the question that they're trying to answer, right? I just named 7 things right there, right, that influence, for example, an agent and how it answers and reacts basically to your requirement that you have. And I bet you most people just say, just put the prompt in and it'll figure it out. Well, it doesn't. And that's the point about this that I want to get across. We go substantially faster with AI-enabled systems. There's no doubt about it. I have created things in hours that are 100% accurate that would have taken me weeks to create using programming languages in the past. But how did I do that? Well, I built scaffolding around it. It goes to what we've talked about on Confab in the past as a part of this. And so that's a really important distinction, obviously, as we go through this, that you really just need to kind of know. So where do you invest your time, right? Because it's like, well, great. Like, Scott, you're telling me all these things I can't do, and that's not what I'm saying. I'm saying don't think that it's not going to take an investment of time. Do you have training when you go to a new business system to understand the forms and fields that you go to interact with, for example, a business process? Yes, you do. Do you customize it or extend it to tackle specific requirements inside of your business? For example, adding a new field or making a process post an additional journal entry to update a statistical value? Yes, you do, right? So in this world, you're going to want to understand how large language models work, because the other areas, for example, with the autonomous agents that are becoming much more popular in our industry, I think the best place for you to start isn't in the data science area. So machine learning models are more focused typically with the data scientist. Expensive, results can vary, got to really understand your data to identify patterning that you want to have as the output that's related to it. They're big projects. Like they're still very big, even though that tooling has become better and better. But understanding how large language models work allow you to automate processes inside of your business. And this is where and why Microsoft is focusing on automated agents as the strategy, and why you're seeing Anthropic introduce all these different types of agents, even OpenAI with the agent framework that they just introduced. Because one of the best outputs of a large language model is taking questions or detail of a decision that needs to be made that's a small amount of data, and then directionally guiding where to go next as a part of that. So large language models and large multimodal models are a substantial factor that you should be investing in your strategy. You don't need to know all the technical underpinnings, but you need to know how it works. And you really do. You need to have somebody, if you've got somebody that's going to be creating or extending Dynamics 365 finance and operations, they're going to need to know X++. Like, you don't need to know every class and method inside of there, but you're going to need to know how a method can be influenced with the parameter that's sent to it, for example, or what a global variable is. Like, you got to understand these concepts at that level to be able to build these effective solutions. And so once again, a lot of leaders that are going to be the managers, you just need to know it's an engine that we're throwing stuff into and it generates power as an output of it. But if you're going to be interacting with it as a creator that's influencing basically the output of that, you're absolutely going to want to know a little bit about how those work. So I want to talk a little bit about it because I do think it's really important for us to know how it works, to demystify this as much as I can without getting too techie with it. Because, you know, if you haven't heard it, like, you'll go to YouTube and you'll watch one of these articles or one of these videos, and there's a lot of good ones that are out there, but the depth that they go into that just becomes so confusing so quickly is part of the other problem that we have, because it is complex. But I guess maybe the best way to describe this is that when we talk about processors and clock cycles and how they work, like how a CPU works, like the billions and trillions of operations a second now that happen on your computer, when all it is ones and zeros that are clicking on and clicking off for transistors, is just mind-boggling. Like what it generates on the screen for you to see, for example. And it's just a machine that has switches that go on and off, on and off, on and off in patterns, right? Like it's just, it's unbelievably complex. And if you were to tell me, Scott, explain exactly how a processor displays at this exact instant what I see on the screen, I would never be able to do that. I could tell you the general concepts with it, but I'd never be able to go through the full trillion-based operations and path that out to figure it out to tell you what it is. So instead, we deal with concepts that help us directionally know what is happening inside of a processor, or what is happening, for example, inside of a large language model. So that's what I want to kind of talk through here a little bit so you kind of understand a little bit more of this detail. So the first thing is that when you have a prompt that you create for a large language model, what happens is that you say, for example, and we'll use an example, smart robot helper, I think is what I have on the next slide here. Like I just typed that into Copilot, right, in the prompt right there. Well, what's it doing? Like there's some magic that's happening when it gets to the large language model. We're not going to talk about like the orchestrator and all the other stuff that's on top of it, but if I was just interacting purely with a large language model, which is what typically drives, for example, this hype and this craze that we're around to be able to generate content and identify patterns, what does it do? Well, really, the first step is breaking it out into tokens. So one of the most important concepts that exist inside of large language models is the concept of what we call a token. Words, imagine it like this. Words are like Lego structures, right? So basically what happens is that each individual word builds something for your Legos. And I love to give this example because my son loves Legos and so does my daughter. So what happens is that each of these are broken out through more complexity. We won't go through how they're broken out, but basically, if I have smart robot helper, I have 3 tokens, smart robot helper, that are going to be broken out that are used then in all these other processes that we're going to describe. So if you put a very large prompt inside of there, one of the things that you'll probably notice if you're a developer on the back end is that it's going out and telling you how many tokens it's going to cost to go through and then ask that question of the large language model. Because each token has an ID or a number that relates to that word. We did this in middle school, right? We took, for example, our particular A, B, C, D, E, F, G, and we assign them a number, 1 through whatever, 26, 27, right? To go through and basically identify then what that letter meant numerically, right? So in this example, what's happening is that there's a token that is broken out with those words and then a number that represents those particular tokens. Not very complex, right? You're probably asking, well, Scott, where does that number come from? Well, part of the priesthood, so to speak, that I mentioned earlier is that when a model is being created, there is a vocabulary that is used, and that vocabulary is part of that training of the model. And we're not going to go into training of models because that's another whole complexity with it. But what we want to know about here is that when that letter or that word, excuse me, is trained, it's going to have then that vocabulary that relates then to that number. So that way we are now turning these into numbers that we're going to use in a machine to do something with. So the very first step here, we take that sentence, we break it out into tokens, and we assign those numbers for each of those words that are interacting basically with that particular token. Now after that, what we do is we do a concept called determining the embedding value. And I'm just like, what does that mean? So Scott, we've taken this word, we've taken a number, and now we've got this embedding value concept. What does that mean? Okay, so imagine it like this. An ID also then has an embedding vector, is what we call it. What is that? So the ID has a number related to it, but instead of just that number, we're going to have 6 other numbers that represent that one number, because that one number might be a summarization of those 6 numbers. And why do we do that? Well, there's a huge reason around this. So when you think about like robot helper, for example, and we'll talk about the pooling in a second here as well, but when you think about the meaning of a word, because what we're trying to get to here in terms of being able to generate accurate output from what we've created for our prompt, we have to understand the meaning or the context of that prompt. Because if we don't understand the meaning of it, we're going to give really inaccurate information. An example I love to give is account. Customer account, vendor account, employee account. Like, what are you talking about? There can be so many different meanings of that can drive it. And so if you think about it from a statistics perspective, what we're trying to do is we're trying to take a scatter plot and put it on the scatter plot for that word to identify the similarities with other words that revolve around that word, right? So inside of our training models, like if I do a 6-dimensional vector, my smart is going to have these values, my robot is going to have those values, and my helper is going to have those values that are related to it. Now here's the thing to know, like I'm showing 6 dimensions here that represent those tokens. Inside of these inside of these large language models, like with OpenAI's ChatGPT, it's 1,536 decimal numbers like this. And in other models like Gemini, it's 4,096 different values that are inside of there that represent that token. It's like, wow, why do we need all that? Well, we'll talk about that in a second, because what we're doing with this potential word is that we're going to be influencing what it's most similar to, right? And that's a really important distinction here, because to figure out what next word we need to say inside of the output, we need to know what's most similar to that word that is constantly used. So if I train something off of Smart Robot Helper, and let's say I had 1 trillion lines of text, and I did Robot Helper and about 1 billion lines of those texts, well, basically what I've done is I've trained more weight towards the content that is having Robot Helper in those paragraphs versus other paragraphs that don't have that, right? So if you think about it just really blanketly, all we're trying to do here is assign a numerical value to try to make it relate to other words as closely as possible. It's that simple. It's not overly complex. It's overly complex in scale, but smart, dumb, right? So we would maybe have the inverse. Maybe it would be instead of 0.20, it would be, for example, negative 0.20 as the very first value in that vector, because that's the inverse of what that word means, right? And so that's how we actually then take these and then in a space try to figure out what words we're going to be interacting with as a part of it. Now, after we've determined our embedding, we have to contextualize it. And what do I mean by that? Well, we need to understand that all of the tokens influence each other. Not dumb robot helper, smart robot helper, right? This is called self-attention inside of our large language models, meaning that other words or tokens, as we call it, but we'll overgeneralize and use words. Other words influence the value of the vector of that other word. And why am I mentioning this? Well, this gets to the prompt engineering that we keep on talking about. So many people have talked through and said, well, why am I getting inaccurate results with this? And why is it pulling in this value way over here? Well, it's because when you did the words that you put inside of the prompt, you didn't activate something that made it so that the vector values went closer to the area or words that you wanted it to navigate to. And this is what's really interesting about this. Like if you take your brain and you look at it where you could look at it through 1,536 different positions of your brain, and when you had a thought, where did that thought go inside of your brain based upon the question that was asked? The context of the value that I give to you or the information I give to you may activate different regions in your brain to get to that output. The same concept exists inside of large language models, and how we pair those together and then how it uses that inputs or affects then what those results are going to be. So once again, this is why it's so important to kind of understand these concepts. You don't need to understand exactly how the vector was calculated in the pre-trained data set to get to it. You just need to know that the words that you put inside of your prompt influence the results that you're going to get. And if you become more accurate with your influence on those, you get better results out because you're activating the right region in the large language model to get that output, just like you would in a human brain, right? So the example I put on here was account, right? If you say, give me my aging account details, well, what do you mean? Vendor aging, customer aging? Whereas if you do customer aging, you're going to be more accurate now in depicting then what that result is going to be. Now, you don't have to say customer. You could say that I am on the sales, credit, and collection side of it. Give me an aging, right? I'd still say you should probably put customer in there to activate the right areas inside of the large language model, but you've already at least provided enough context where sales typically means customers because it's related in vector to sales, and so therefore it's going to be influenced to kind of then directionally be more accurate with it. This isn't right. It's not rocket science, right? As we go through this, but the net result, just know that your prompt, and this is why your prompt matters so much, impacts this. This is also why team numbers are horrible for large language models. What large language model is trained off of the statistical numbers of patterns of data? That's not how they're trained. They're trained off of text data, for example, and educational books and Reddit posts and all these other types of narrative data that's inside of here. So if you try to then use a large language model for numbers, what a large language model does actually is that it takes the question that you asked and then it tries to figure out those numbers in terms of the components of those numbers. And a lot of these then actually send the number or mathematical operations to different specialty models that then do the calculations. So once again, you got to just understand that that's why vectors are so important and why narrative content works with large language models so much better as you go through that process. The final step here is the concept called pooling. Great. We identified all these individual vectors for all these different types of values. Scott, I've got these values now. I need to know the meaning of, the meaning of this prompt. Because the meaning of this prompt is what I'm going to be sending to the large language model, or what I need to look in my database of information to get the content out of that large language model. So what happens after the pooling occurs, the contextualization occurs, is we pool that data. We basically create a meaning of that prompt, which we call the semantic meaning of that particular question that was asked. This is important once again because this drives then what data would be actually accessed inside of the large language model to get to that output. And here's another really interesting thing about this. You think about all these arrays of numbers, right, that we deal with, and maybe this will make sense to you as well on why these systems are so complex. Because think about it like this. You download let's take our open source models that we have, and we'll take some of those models that load into more than three 64 gigabytes. So we'll say 160 gigabytes of VRAM for some of these extremely complex models, or GPU memory. Just imagine this, like you send a prompt over to it, each one of those words has 1,536 decimal values that is related to that word, that then has to do all these amazing things to balance and figure all of it out, and then from there provide and look into that large language or the inferences data to then get you output that statistically is going to be the next letter or word that needs to be generated as a part of it. That's why these are so computational power intensive, right? Because they have so many values that they use to get that directionality along with all that data that is stored inside of the inference large language model. So this is a really important concept, right? What I'm trying to teach you here, just at the most basic level, is that 99% of the time, the reason that AI systems fail in terms of the interaction with them is because the prompt is not well thought out. If the prompt doesn't know how to activate the regions to create the content, you're going to get very bad results. The other portion of it is that you're trying to use data that hasn't been pre-trained. And it doesn't matter if you use some of the other concepts such as retrieval augmented generation, or what we call RAG, where we add or append data to it. If a model hasn't been trained off of it, the accuracy is not going to be as impressive there. So just note that this concept just needs to kind of be known as you go through this to really drive some of the processing inside of these large language models. The final thing to note here, and this is where GPT-5 is going to come into play here as well in the future for you, is that the prompt matters, but you can only process so many tokens at once, right? So imagine these architectures where we've got a vector, and let's say then that I'm overly simplifying this, but let's say that we can only process 4,096 vectors at once of 1,536 values. It's almost like memory, meaning you can only send so much data to the large language model for it to then process and do all these steps that we just talked about. And then what does the model have to do? It summarizes the context of that chunk, includes that with the next one somehow magically on the back end, and then processes the other portion of it. But what we see is that we don't have the full context then of the statement or of the data that was asked as part of it. And so that's why then when you send large amounts of data, it's summarizing some of the data to start, then taking another chunk and summarizing it, and doing another chunk and summarizing it. And the context might actually span across the entire statement that you made. So it's important for you to be successful to do the chunking out ahead of time to improve the accuracy. So instead of making one massive prompt, figure out how to make smaller prompts that give you really good, accurate results that you can then generate summary narratives off of to then go ahead and generate content off of, while including additional detail around that as well. This is huge when it comes, obviously, to how large language models work. I guess the big thing here is that if you've got a 10-gallon tank, if you send 50 gallons in it, you got to let that engine run a little bit before you can add another 10 gallons to it, or 5 gallons, or wherever it may be. Same concept applies here. You need to figure out if you're sending a large set of data, and that data typically should be narrative data like emails, text messages, questions maybe that have a summary of some small subsets of data. Those work really, really well. Now, one of the things I just want to kind of leave us with, because we're getting to time here, is the fact that while we've talked through a lot of this content from a much more technical perspective here, GPT-5 changes this. And I think every model will in the future here. So just as an example, GPT-5, instead of 64,000 characters at around 92% accuracy, I can send it around 256,000 characters at that same accuracy level. So every model release that we're going to see, one of the concepts is this what we call the MCRC is being improved to allow for you basically to actually go through and then from there send more data to the large language models. But once again, the question will be for you, is it the right use case for you to do that? Should a large language model take terabytes of information and summarize it for you? And the answer right now, and probably for the next 5 years, is no. Instead, large language models should take, for example, emails, should take prompts of questions that you have that result in data output, should generate content, can do basic decision making that's regarding it, such as when I get these 5 different emails, what is the intent of the email that directs me then to go to inform somebody or another AI system to do something with that content, right? To then take that email and identify the response that I should do, or escalation that should happen to a customer service agent. Or, for example, if I take the content of credit and collections and I give you one little record of 30, 60, 90, 180 day, and I say, pretend you're a credit and collections agent, analyze this aging and tell me what areas I should look at with it. Well, that is trained because that's context that is in different types of college books that state how a credit and collections manager should interpret a 30, 60, and 90-day balance, which means it can drive off of that knowledge to then apply some of those scenarios then to the data that was provided with it. But we're not going to be dealing with large subsets of data to be able to do that. So I know today was a little bit deeper than what we went through, right? And I really do appreciate all of you coming on. I wanted to go through and do this because, quite candidly, if you go through these design patterns and you understand a little bit more of how this works, it's going to make it way more successful for you. And with GPT-5 and with some of the other models that we're going to start seeing introduced here, it's going to be just a ton more that we're going to be able to tackle. And we would love to be able to help you on this journey. If you've gone through this and you haven't been successful, reach out to us. If you have gone through it and it's not working, reach out to us. The big thing that we can do is we can help you directionally understand where you should invest and what strategy you should invest in as you go through this. That way you're successful, obviously, with your automation needs inside of your business. So with that, thank you all for your time. Have a great rest of your week, and we'll talk to you on the next confab. Have a great one.